In this video, we'll continue talking about series and their convergence or divergence. So I'm going to do a few problems. Let's look at the first one. Use the integral test. So they specify again which test to use to determine the convergence or divergence of the following series, or state that the conditions of the test are not satisfied and therefore the test does not apply. So the integral test, it's integral from 0 to infinity, right, because we start at 0, 1 over square root of x plus 8 dx. So we know that this is an improper integral, so I'm going to write limit as n it's approaching infinity of integral from 0 to n of 1 over square root of x plus 8 dx. I'm going to use substitution, so u equals x plus 8, du equals dx. So we get limit as n it's approaching infinity integral of, now if x is equal to 0, u is equal to 8. So we start from 8, and if x is approaching infinity, u is going to approach infinity. So then it's going to be 2n of 1 over u, 1 over square root of u. So it's going to be u to negative a half du. So we can calculate this as u to, let's put limit, as n it's approaching infinity, of u to negative a half plus 1, that would be a half, over a half, so I can put a 2 in front, evaluated from 8 to n. So we get limit, as n it's approaching infinity, of 2 square root of n minus 2 square root of 8. Now as n it's approaching infinity, this it's approaching infinity, infinity minus a number, it's infinity. So because the limit of the integral is infinity, then the series diverges. I also was thinking when I saw this at the P series, right? This one is sum as k goes from 0 to infinity of 1 over k plus 8 to the 1 over 2. So this looks like a P series. Maybe I can translate it into a k goes from 8 to infinity of 1 over k to a half, right? This the same thing. When k equals 0, I get 1 over 8 to the second. When k equals 8, now I get 1 over 8 to a half here before. So this is a 1 over 2 P series, and we know that when the series, the P equals a half, or 1 over something is less than 1, then it diverges. Anyway, we had this like a second method. Let's take a look at this problem. Use the integral test to determine the convergence. So again, I'm just going to set up the integral for you. Integral from 1 to infinity of x over x squared plus 1 to the third dx. And I'm going to try to solve it using substitution. So u equals x squared plus 1. Du is 2x dx. So I can see the x dx, but I would need the 2 to actually have the whole du. So I'm going to multiply by a 2 here and divide by it. So we actually get 1 over 2 integral of du over u. Now if x is equal to 1, this limit, u is going to be 2. And if x is approaching infinity, u is going to approach infinity. So this integral here is going to be 1 over 2 limit as n is approaching infinity. I can calculate this integral right away, ln of absolute value of u evaluated from 2 to n. So we get a half limit of, as n is approaching infinity, of ln of absolute value of n minus ln of 2. So, and we should put a half there. Now this ln of infinity is infinity, so we actually get infinity. So again, the series diverges. Now, if you are wondering how I got that ln of infinity, it's infinity, right? Let's take a look at the graph. Now, ln of x. If x is 0, let's say if x is 1, we get 0. If x is 2, we get something. If x is 3, we get something. Now, if x is a half, we get -1. So basically, the graph of ln of x looks something like this. So as n is approaching infinity, as it gets bigger and bigger, the value of ln is approaching infinity. If I had to find the limit as n is approaching 0, for example, of ln of n, I would have said as x is approaching, right, as this one is approaching 0, the value is approaching -infinity. Just something for the future. So let's take a look at another problem. Use p-series, right, to determine the convergence. So what I'm going to do, I'm going to rewrite this by shifting 2 units to the right. So what's going to happen is this one is going to be k to the 4th. And if k was 3, this was actually 1. So what does that mean? I should start with k equals 1 to infinity. So I actually added a 2 to k minus 2, and I actually subtracted a 2 from k equals 3 to generate exactly the same terms. Just think about it. If k equals 3, we get 1 over 1 to the 4th. If k is 4, we get 1 over 2 to the 4th. If k is 5, we get 1 over 3 to the 4th, and so on. If k is 1, we get 1 over 1 to the 4th. If k is 2, we get 1 over 2 to the 4th. If k is 3, we get 1 over 3 to the 4th. So basically, we're generating the same thing. By doing this, we are showing that this is a p-series, right? P-series, where p is equal to 4, and because it's greater than 1, the series converges. Another way you can prove this is by calculating the integral, right, using integral test. So now let's take a look at more problems. What's interesting here is it says determine whether the following series converge or diverge. They are not telling us which method to use. So let's make a quick review what tests we learned. So we learned divergence, we learned integral, we learned p-series. So let's try the first one. So this is a sub n. So if we do limit as n is approaching infinity, or maybe I should start with k since we are using if k is infinity, of square root of k plus 1 over k. Well, because the degree of the numerator is the same as the degree of the denominator, it's actually equal to the ratio of the coefficients, so 1 over 1, which is actually 1. And the divergence test was saying that if you calculate the limit and the limit is not equal to 0, then the series diverges. So in our case, is not equal to 0, and we can say series diverges by divergence test. So make sure when you're doing this on a test that you actually write it this way so that I know which method you used, do you know what method you used, and so on. Let's take a look at this problem. So again, out of these three, I'm going to use divergence test. We start with the first one, right? So it's going to be 1 over 3k plus 1 times 3k plus 4. And if we evaluate at k equals infinity, we actually get 0. And the divergence test said this theorem cannot be used to determine convergence. So what happened, the value that we got, 0, we don't know, it's telling us that the divergence test, by divergence test, it's inconclusive, right? So inconclusive. I cannot say that it's divergent or convergent, so we'll have to come up with another method. Now the way it's set up like this, it reminds me of partial fractions. So this was a method that we found inconclusive. Now we try another method. So I'm going to do the partial fractions. So please pause the video and try to figure out what A and what B, as we set them up this way, are going to be. So I did the computation and I broke down the fraction, and then I opened the parentheses here and I combine the like terms. So we factor out the k, so the terms 3a plus 3b equals 0, because the term with k here is 0k plus 1, right? So that's why it's 0. And then the terms by themselves, 4a plus b, it's equal to 1, this one. Okay, so then we calculated and we ended up with a equals 1/3 and b equals negative 1/3. What does that mean? Well, it means that our S sub n, if you want, is equal to a over 3k, so it's 1 over 3 times 3k plus 1, minus b, it's 1 over 3k plus 4. So we get sum as k goes from 1 to n equal to that. So 1/3 comes in front, and now I'm going to start giving values to k. If k equals 1, I get 1 over 4 minus 1 over 7. If k equals 2, I get 1 over 7 minus 1 over, k equals 2, 6, 10. If k equals 3, I get 1 over 10 minus 1 over 13, and so on. And let me put the n term, 1 over 3n plus 1 minus 1 over 3n plus 4. So this cancel. Now this one is going to cancel with the one before, so S sub n, it's 1 over 3 times 1 over 4 minus 1 over 3n plus 4. So when we calculate the limit as n is approaching the infinity of S sub n, we actually get 1 over 12, because this quantity is going to approach 0 as n is approaching infinity. So what happened? Well, we just proved using the partial sums and using the partial fractions that our series is actually converging to 1 over 12. Let's take a look at a couple more problems. So here again we have to decide if it converges, and we have to make our own use our own method. What I'm going to do, I'm going to use integration. So this one, it's integral test. So it's integral from 0 to infinity of 10 over x squared plus 9 dx. So limit as n is approaching infinity of integral from 0 to n of 10 over x squared plus 3 squared dx. 10 comes in front, and so we get limit as n is approaching infinity of 10 times. Now the integral of 1 over x squared plus 3 squared, it's 1 over 3 arctangent of x over 3. Evaluated from 0 to n, which gives us 10 over 3 times limit as n is approaching infinity of arctangent of n over 3 minus arctangent of 0, which is 0. So 10 over 3 times arctangent of infinity over 3, which is infinity. I want to remind you that at pi over 2, the graph of the tangent goes to infinity, right? So this is how it looks, the graph of tangent. So what does that mean? It means that arctangent of infinity is going to be pi over 2. So the answer is 5 pi over 3. So this series actually converges. Series converges. And just a quick hint for this one, I would advise you to split it in 2 to the k over 4 to the k and 3 to the k over 4 over k, and you have two geometric sequences which you can easily calculate.